Hi, my name is Jakub and I will show you how to solve the first example from today's problem set about treasures and traps behind mysterious doors. I will not read the problem statement here. What I will do instead is I will explain what are we doing in general, right? We will have some doors, and behind those doors can either be a treasure or a trap. Each door has a sign on it with a statement, and that statement can be true or false. And that statement will tell you something about the location of treasures and traps. And in general, we assume that behind each door there either is a treasure or a trap, so there cannot be anything else. You only have two possibilities, right? In addition, every time we will get a sentence from a guide which tells us that in this particular room something about those statements is true, right? So it might tell us that in this room both statements are true, in this room both statements are false, or something like this, so something more complicated. And we will start with the first example by just going and putting the doors and the statements out there, right? So let's begin. In the first example we have two doors, and the first one has a sign that says there is treasure behind this door and a trap behind the other door. And the other door has a statement that says behind one of these doors there's treasure and behind the other one there's a trap. Okay, and our guide that is never wrong tells us that one of the signs in this case is true but the other is false, right? So let's think about it, right? So we have two possibilities, right? I'm writing over myself. Two possibilities, right? So either this one is true, right? Either this one's true, and that would mean that this one's false, or this one's true, and that means that this one's false, right? So in order to solve this problem, we need to consider both of those cases and show that only one of them works, only one of them leads to a position of a treasure. Or maybe they both work, but they both lead to the same result. If you're solving a problem like this, you need to consider some cases, right? And you basically have to consider all the cases in some way in order to show that there is no contradiction, right? The problem that we're going to solve today are all well constructed. They all have a unique solution. So there's never any contradiction. It's a riddle you can always solve, right? But you shouldn't assume that it is the case. Mathematically speaking, you always want to show that there must be no other way of solving this problem. There might be no other way. There's no contradiction, right? There's not the case. It's not the case that if you assume that one of the signs is true, for example, the other is false, you get no contradiction in one solution, and if you assume otherwise, you also get no contradiction and a completely different solution, right? Every problem has to lead to a precise solution, to a unique solution, and if you to have a full solution of a problem in today's problem set, you need to always consider all the cases. So let's begin. The first case is that the door on the left, this statement here is true, right? But the other one is false, right? But let's think about it, right? If this statement is false, right, what does it mean? The statement says behind one of these doors there's treasure and behind the other one there's trap, right? So it doesn't say which one, but it just says that there is one trap and one treasure. So in the beginning we had four possibilities: two treasures, two traps, or trap treasure, treasure trap, right? This just eliminates the two possibilities that there are two treasures or two traps, right? But if that's the case, that if we have a look at the first statement, right, the first statement precisely says there is one treasure and one trap, right? So if you assume that this one's false, what that means that there's either two treasures or two traps, right? So if this one's false, then this one also must be false, right? And conversely, if this one's true, then this one must be true, right? if the first sign is true, the second also must be true, because if there's treasure behind this door and a trap behind this door, that means that behind one of them there's a treasure and behind one of them there's a trap, right? So what I mean is that if this one's true, then this one also must be true. And so it's not possible for this one to be true and this one to be false, right? So this doesn't work. We know that this doesn't work. Sometimes we draw like the lightning bolt that says it doesn't work. So we need to move on and consider the other possibility. The other possibility is this one, is that this one's false and this one's true, right? And in this case, we know that one sign is true, the other one is false. So there is no other possibility. There are only two cases. We've considered the first one. It led to a contradiction. It was incorrect. So we had to consider the other one, and you already know that, probably if this problem is constructed well, if the riddle, has a solution, this is going to be the solution, right? And we know that, well, behind one of these doors there's a treasure, and behind the other one there's a trap. If treasure is here, right? If the treasure is here, then there must be a trap here, right? But that would mean that this statement is true, because this is exactly what it says, and we already found that this one's false, so it can't be the case. The only possibility is that the treasure is in fact here, right? There must be treasure behind the right door and the trap behind the left door, right? So we open the right door and we find the treasure, right? I hope that wasn't too confusing. And in my solutions that I will show you, I will basically go through all the wrong cases first and go to the right case, correct case at the end. If you are solving, you will not be as lucky, but remember to have a proper foolproof solution, you have to consider all the cases, even if the first case that you consider already sort of gives you the answer, right? Then it's like, okay, this gives me the answer, so I have to look at the other cases and confirm they give me some sort of contradiction, or they gave me the same answer, right? If you just consider one case and it gives you some answer, is not enough to say the problem is fully solved, right? Good luck. 2 more examples to come, but for now, see you later.